Okay, these are the Model 11 Part 2 notes. This is page 5. So I have given you the formula up top, which looks fairly complicated, and it is. So we are definitely not going to use that to calculate binomial probabilities, binomial distributions, or the probabilities of binomial distributions. We are going to use Excel. For this page, I am going to go ahead and write down the Excel command. So you have a chance to just type it in, double check, make sure you get the same numbers I'm getting. And then there are video Excel examples for example 9 and 10 on the next page. So this is the information from the previous page. This is our adult smoker study. We've got N equals 10. The probability that they started smoking before 18 is 0.8. We want to see if in our random sample of 10, what the probability is that 8 of them started smoking before they were 18. In Excel, you are going to use this command. If you start typing binomial, this is the very first thing that comes up, binom.dist, binomial distribution. And so I am going to list what we're putting here, what it's going to ask for. Keep in mind, you can always click on the hyperlink. It will tell you what you need to input and what it means. So the first thing is the number of successes, so that's what our X is. The second thing it's going to ask you to enter is the number of trials, so there's our N. Then it's going to ask for the probability, and then it's going to give you an option for true or false. If you pick that, it's cumulative, whether we want the probability just at this value or whether we want it up to this value. Now, this is a little tricky with binomials, and when we use Excel to do the normal distributions, it's going to be different. But here, for a binomial distribution, we are always going to end with a 0. Our cumulative is 0. So here is what I plugged into Excel. Binom.dist, equals binom.dist. The number of successes we want here is 8. Our number of trials is 10. The probability here is 0.8. And our cumulative, because we just want that point, is going to be 0. Parentheses and close. And I get a probability of 0.3020. So a 30% chance out of my group of 10 randomly selected smokers that 8 of them started smoking before they turned 18. Example 6, we're on our Clarinex D example. Our sample size is 20. Our probability is 0.05. And the number of successes we want is 3. So here we have equal binom.dist. We want 3 successes out of our 20 trials at a 0.05 probability. Remember, these all have to be decimals. Closing with a 0, and we get 0.0596. There's the probability that exactly 3, 0.0596. Let me fix this up here. I was running out of room and I forgot. Probability that x equals 8 is 0.3020. And last example, 8 here. We have got a sample size of 10, a probability of 0.6, and we want to know what the probability is that exactly 5 students are successful. So binom.dist equals binom.dist. 5 out of 10 with a 0.6 chance of success. Closing it off with our 0, and we get 0.2007. So the probability that exactly 5 of them would have been successful is 0.2007. And none of that is bad, easy enough to do, individuals. This next question, though, is why we really want to head to Excel and look at some of these examples. What if we wanted to know the probability that 3 or fewer of them would have been successful? So I need to start at 0, add 1, and the probability that we had 2, and we know in Excel this is fairly easy because once I get it in there once, I can just copy and paste. Oops, that's a 3. And drag and copy these. So it is just kind of important that we keep track of everything. And so this is going to carry into the one below. When I figured this out, I had, let's see, 0.04247, 0.01062, 0.00157, and 0.00010. This is a 5. When I add all those together, the probability that x is less than or equal to 3, I get a probability of 0.0548. Please don't hesitate to check my Excel numbers and my math and let me know if anything seems at all sketchy. Wouldn't be the first time.